welcome back to your favorite technical mathematics class. We're going to take a look at volume. We're going to start out with a little introduction, right? We've previously looked at perimeter and area as measures. Another measure is volume, or the amount of space occupied by a figure. For example, how many cubic feet of water does a pool hold, right? That would be an example of volume. So let's look at these here. Initially, for a rectangular solid, you have length times width times height. If it's all the same lengths, like for a cube, then it's just side times side times side. And that's telling you, like for example, with a pool, right? How many cubic feet of, let's say, water you'd have. But let's go ahead and do it for this one. We've got length times width times height here. So the volume, length times width times height. So 20 centimeters times 8 centimeters times 16 centimeters. And of course, centimeters times centimeters times centimeters is cubic centimeters. So it looks like this ends up being 2560 cubic centimeters is the volume for this rectangular solid. Let's do it for a right cylinder. So for a right cylinder, if you remember, the area of a circle's pi r squared, right? So you've got this base of pi r squared, right? That's the base, the circle. And then you multiply it by whatever the height is. And that'll give you the volume of a right circular cylinder. So for example, for this one, pi r squared h, find the volume of a cylinder with a diameter. So they're telling us the diameter all the way across is 11 meters. So the radius would be 11 divided by 2, right? So since the diameter is 11, then the radius would be half the diameter. So the radius is half of 11, or 5.5 meters. That's our radius. So let's put 5.5 in. 5.5 meters is squared. And it has a height, looks like our height of 14 meters. And then it also says, interestingly enough, don't use your pi button. Instead, just use 3.14 and approximate it with that. So we got 3.14 times 5.5 squared. I'm going to go ahead and take 5.5 and multiply it by itself. 5.5 times 5.5, I get 30.25 square meters. Still got this 3.14. Still got this 14 meters. Let's take it up here. So 30.25 times 14 is 423.5, and I have meters times meter square, so now I'm in cubic meters. So now lastly, I just multiply by 3.14, and so I get a volume of 1329.79 cubic meter, meters cubed there. Or if you want to round, it says round to the nearest tenth, I'm sorry. So I should have rounded that to 1329.8 cubic meters, because the 9 to the right of the 7 will bump that up, right? Let's do the volume of a pyramid. So the volume of a pyramid is 1/3 area of the base. So whatever this area, that base, that's the capital B, right? That's the area of the base right there. So let's do it for the Luxor Hotel. So the Luxor Hotel is said to be based on the same shape as the Great Pyramid of Giza. So let's see how its volume compares to the actual Great Pyramid. The Great Pyramid of Giza, the actual Great Pyramid of Giza is 91 million cubic feet. So let's find what the Luxor Hotel here in Las Vegas, its volume is, okay? It says it has a square base, Okay, it has a square base of length 600 feet. So 600 feet by another 600 feet. So when you're doing the volume, 1/3 area of the base, that capital B, that is the, in this case, the area of the square base. In this case, it's a square base. So it's 1/3. Now I got 600 feet times the other 600 feet. That's the area of the bottom. And then the height, looks like the height is 350 feet. This is the height. The height is 350 feet for the Luxor Hotel here in Las Vegas. Well, 600 times 600 is 36,000. So 360,000. Whoops. It's got square feet now. Feet times feet. I'm going to multiply that by 350. I get 126 cubic feet now. Feet squared times feet. So 126 with 6 sixes. And then take 1/3 of that. So divided by 3. Okay, let's see. 1, 2, 3, 4, 5, 6 zeros. Yep. So 40. So the Luxor, which is supposed to be the same shape as the Pyramid of Giza, it looks like it's 42 million cubic feet. But the actual Great Pyramid is very large. It looks like the Great Pyramid is 91 million. So quite a bit bigger. The actual Great Pyramid of Giza. That would be very cool to see, to go over there to see the pyramids over there. So not as big. So now we get into volume of a cone and a sphere. So here's your equations for these. So volume of a cone is 1/3. And then area of the base, well, the area of the base here is pi r squared because it's the area of a circle, and then times the height. Okay. For a sphere, you've got 4/3, and then pi r cubed will work out for your volume of a sphere and volume of a cone. Right? So let's go ahead and do volume of a cone here that has a radius of 3 meters and a height. If I could draw this, not very good. Looks like it has a height of 9 meters. So we got 1/3 pi r squared times h. 1/3 pi, our radius here is 3 meters squared. Our height is 9 meters. And it says to use 3.14. And let's go ahead and square 3. 3 squared is 9. So 9 meters squared times the 9 meters. So we got 1/3 times 3.14 times 9 times 9, 81. And then meters squared times meters, meters cubed. So now I'm going to go 81 divided by 3 gives me 27. And then 27 times that 3.14 gives me 84.78 meters, cubic meters. Now we want to round to the nearest tenth. So 84.8 will be the volume of that cone. Now, how about this one? A basketball. So basketball with a diameter of 9.518. Okay, so here's our basketball. If I could try to draw a basketball. But they're giving us 9.51 all the way across is the diameter. We want the radius. So half of 9.51 is 4.755. So radius would be half of 9.51 or 4.755. Okay, so for the basketball, volume of a sphere is 4/3 pi r cubed. So I'm using this one up here, right? 4/3 pi r cubed. So we've got 4/3 pi. Our radius is 4.755. We're going to cube that. So if I cube 4.755, and I'm going to go ahead and we'll go ahead and use pi. That's 3.14 again. And 4.755 cubed gives us 107.5106689. So I'm going to multiply that by 3.14. And then I'm going to multiply that by 4. And then finally divide it by 3. So in other words, times 4/3. So this volume ends up being... And you know what? It looks like in my answers here, I actually use the actual pi button. So let me, instead of 3.14, let's go ahead and use our pi button here. And let's go ahead and do that together. Let's show you on the decimals here. So let's see, decimals. So we have 4/3 at the beginning times pi, use the pi button, and then it was 4.755 cubed. So the nice thing is this will just do it all for you at once. But if you want to do it in order, it'd be 4.755 cubed, then times pi, then times 4, then divided by 3. But we got 450 if you use the pi button instead of 3.14. A pi button, of course, being more exact. So 450.339. Write that down. .339 or whatever that was. 6367 maybe, I can't remember, but we're rounding to the nearest. We'll go to 100th here. So 450.34 cubic inches. Okay, that's for the basketball. Now let's do a volleyball. Now the volleyball has a diameter of 8.39 all the way across the circle. So if I take half of that, I'd have a radius of 4.195. Okay, so my volume of a volleyball would be pi r cubed, 4/3 pi, radius 4.195 cubed. Let's punch that in. And we get 309.2320537 cubic inches. So if I round it to the nearest 100th, 0.23 cubic inches. So the difference, on this one they ask you find the difference, in other words subtract them between the two. So 450.34 minus 309.23. You get 141.11 cubic inches. That's how much bigger the basketball is than the volleyball, right? The basketball is 450.34 cubic inches. The volleyball is only 309.23 cubic inches. So the difference between the two is 141.11 cubic inches. Thanks so much for watching, you guys. Hope that helps you out, get you started. See you next time.